Hey folks, we're here on to chapter 1.3, and look at this, I found I can actually type now, so you don't have to see my terrible handwriting all the time. I can use the right tool. 1.3, this is introducing the database. Move this guy over here. There we go. So a database, again, is the tool that we use. It's the piece of software that we use to manage data. So it has a bunch of things inside of it. So one of the things it has is the raw data. Right? All of those dates or numbers or dollars or yes or no, any of those pieces of data we can store in a database. But what you also have in a database is you have this thing called metadata. Now, metadata is super important because it's data about the data. So it's telling us things about the data to provide us context so we can better derive information from that. So the metadata is its characteristics, its relationships. You might also hear the term data dictionary when we start talking specifically around database management system terms. So it tells me that this piece of data represents this, or this piece of data has this characteristic, or all IDs in this table for my student IDs are going to have 7 digits. That's a piece of metadata, data about the data that we can use to derive better information out of it. So we have raw data, we have the metadata, which is the data about the data. And typically what we're going to do, because we actually store metadata in the database, you have data about the data, you have the data, and it's sort of this self-describing process. So the data is self-describing because we can store metadata that tells me about the data. So the data can describe itself, and all of that is stored in the database management system. So the database management system, or DBMS, database management system, is all of the programs that manage the data. They manage the structure, they manage the access to it. So it's a powerful tool to make sure that we can do all the things that we want to do with the data. So the database management system has many roles. Right? One of the things it does is it manages access. So it says who can access what, who can insert data, who can read the data, who can manipulate it, who can do other things, who can change the metadata about it. Because a lot of times what you're going to have is you'll have this process of designing a database that we'll talk about next section, and some people should design it and other people should be entering the data and using it here. We want to kind of separate those out. So our database management system is typically interacted with through other pieces of software. Right? Most people don't interact directly with that database. Right? They'll work with a piece of software that then talks to the database. And you can take some of the other programming courses. We'll do some cool database stuff. So pieces of software work with the database management system. So the database management system not only manages access, it helps share the data. So if we only ever had data on pieces of paper, only one person could have that piece of paper at a time. And I guess you can make photocopies of it and have multiple copies of that data floating around. But then you're going to run into problems, right? If you have this piece of paper with this form, right? We say, hey, this is the customer file. You know what? Okay, let's not do customer. Customers are boring. How about we look at someone's medical record? Because that's more fun, right? This is someone's medical record. And we'll say, okay, they have allergies to Tylenol. Right? So if they're allergic to Tylenol, we should not be giving them Tylenol. This is in your medical record. Right? And now we can make a copy of this, right? If someone else wanted to see it, and now we have, another version of that with your allergies on it. But then if you take that record, Tylenol, that's not important how it's spelled. If you take that record and you go somewhere else and you find out, oh, hey, when you're working with this doctor, you find out you're also allergic to some other medicine. They would put that on this piece of paper over here. You're allergic to these other things, but that never got put back on the original record because you're working with a copy of it. And that's not great. Right? That's all sorts of problems are going to arise if you go back and they don't know you're allergic to these things. So having a single central location for that, where we can share the data and everyone works with the same set of shared data, is a huge advantage of database management systems, because it lets me share it across multiple users, multiple applications, wherever, whatever it needs to be, right? No matter where you go, if you log into your Gmail account, your email account, you'll have the same emails, right? You don't have multiple copies of them anywhere. You all just access the same central version from no matter where you are. Another job of our database management system, right? It manages access, it shares data, it makes sure that we integrate all of the views of the data, so it integrates. So many times what you have here, you might have sales data from some company, you might have production data of the pieces that they make, that they are selling, you might have HR data for human resources, you might have other sorts of interesting pieces of information. All the different users might care about different pieces. But we can integrate all that data into a single system, because if HR knows who you are and we want to track who's producing the part, right? We don't want to have to put a copy or put your name down every single place on every single sales record you did, on every part that you produced, right? We want to be able to link to that and say, okay, it was produced by this person, here's his record. It was sold by this person, here's their record. And then if something needs to change, if you change your name, right, we can change it in one place and it will automatically be picked up by the other locations, because we're sharing that same view of the data. So our database management system does a lot of things. It's a really important tool. Another thing, right, it will improve our data security because we're managing the access, right? It improves the data sharing because it's designed to share the data. It will integrate the data better here. And because we're able to share the data, we're able to reduce data inconsistencies. This is a big problem here. Data inconsistencies. Consistency. Right? So if you go to a Meyer, that's how you spell Meyer, right? Wow, spelling is not my strong suit. So if we go to Meyer and they say grapes are on sale, because that was in the ad, and they are now $1.29 a pound. That's LB for pound, because why not wouldn't there be an L in the word pound? Right, we're going to sell our grapes for this amount. That was what was in the flyer. This was Meyer, the corporation here, right? They sent out the flyer, and they said, hey, we're having a sale on grapes across all of our stores. If you go to your local Meyer, and they didn't update their system, if they had a different copy of that, or if they were tracking it separately, if they had grapes at a different price, if they were still $1.99 a pound, you're going to be really sad, right, if you get charged the wrong price for it. So a data inconsistency is a big problem, right? Or even in this HR database, if we wanted to track someone by their full legal name versus a nickname, right? I have a daughter, Genevieve, with the J, because all the kids have J names. Genevieve, she usually likes to be called Vivi, V-I-V-I. So in one system, if you say Vivi sold this, but in the HR system you said it's Genevieve, they're not going to link. They're not going to know that that's the same person here. So we want to have a single source, a single record there, so we don't have those data inconsistencies. Our data sharing, improved data access, a little bit different than data sharing. So our data access is improved with a database management system because it lets you run reports on data. Right? You can get live views of the data that you have there. You might have a built-in report, or you might be able to do an ad hoc query. So ad hoc queries are a lot of fun. This is just, on demand. I want to know something here, so I can go ask the database for some information and get out current things. And it doesn't have to be a pre-built report. So reports are typically pre-built, right? And they'll show me something. The ad hoc, I can go in and I can narrow it down. I can kind of slice and dice it a little bit here. And with an ad hoc query, I'll say, hey, tell me all of the sales that were greater than $1,000 this month. Right? Who came in and bought a bunch of stuff? And what things are they buying? Right? Well, it turns out we've got a holiday coming up. We've got Labor Day coming up. So maybe people were coming in and stocking up to have a Labor Day party. Right? And so if we can see that we're selling all sorts of products for Labor Day parties, maybe that's the kind of thing we can advertise and target and try and get more people to come in and spend lots of money here. So when you do an ad hoc, you'll call it a query. That's query like a question that you're asking the database here. You'll get a result set back. That's our technical term here, our query result set. Result set. Okay, that's all the data that we're getting back. That's all the data returned by our ad hoc query. Another benefit of database management systems is we get better decision making, because it helps us collect all of the data and derive better information from the data that we have. Right? And we're going to get better decision making, and we're going to have better data quality as well. The data quality is going to improve because we're not having to enter all the same things on every single form every time. Right? We can say, hey, here is that record, or here's this person who did the sale, here's this piece of information, here's the price of the product at this given time here. So it's likely to improve the data quality and give us better decision making, because we can then, when we want it, go look up the information in this central repository. Right? If we were selling widgets, we could see, hey, which widgets are selling better? Which ones are more popular? And we can make sure we're planning to have capacity to sell those widgets. Right? A lot of times, if something is really popular, they might run out of stock. And if you're out of stock and you can't sell the product, you might be losing money. Right? And another advantage is increased our end user productivity. That's the end users productivity. They're able to better do their job because they have the information at hand. They don't need to go look it up in a file system somewhere. Right? So there's just some of the advantages of using a database management system. Now we're going to look at different types of database systems. DBMS. Lots of different types of database management systems. So a common one is a single user. Think Microsoft Access, MS Access. Right? Designed for a single person, really. They open it up, they do all their information, they would do whatever they want in there, and they close it down. Right? If someone's using it, you have to wait. There's technically ways you can share Microsoft Access database. It is not enterprise quality. It's not designed to be a multi-user database. That's not that. So single user database or desktop database, you might also hear. Now, there are good reasons for these and good purposes for these. A lot of pieces of software that you might run on your computer will have a single user or desktop style database for tracking its information. And because you're the only one using it on your desktop, on your computer there, that's fine. It doesn't need to manage that multi-user support, but that it gives it a database management system to store its data behind the scenes. Well, that's fine. There's nothing wrong with that, but it's designed for certain purposes here. More common, especially when we talk about enterprise level, is the multi-user user database, designed for multiple people to be using it at the same time. People can be entering data, people can be querying, people can be running reports, all across the different views. Anything that we want at scale, we can have people using at once. From here, I've not heard this very common, but they'll break it down into a work group size versus an enterprise size. So work group is like, say, less than 50 people. Enterprise is everything more than 50. I don't think that's a very interesting distinction. So typically the number of different users using it at one time will help us decide that. Another way of classifying databases is location. You might have a single central database. Right? There is one database server, and everyone connects to that one, and all the data is there just on that one database. And this is common, it's easy, it's easier to manage for sure. But the other version, as you might imagine, if it's not centralized, it is distributed. Now this is the cloud scale. You'll expect this from the large service providers. So Google, Amazon, Netflix, all the big people use distributed databases so they can have multiple copies of their information in different physical locations because it increases speed. So distributed is much more work to manage typically, but you're going to get better speed. And especially if you're a global company, you don't want everyone to have to connect to your one server in one location, right? You want to have redundant data to make it faster and easier for them to access. So you might have a distributed database system there. And there's a whole chapter on that we actually don't get into. That's a little bit more of an advanced topic. So many of our cloud databases, quote, quote, cloud is just someone else's computer. Someone else's computer are run with distributed databases. So that's what they do behind the scenes for us. So Microsoft Azure, Amazon AWS, IBM is trying to get into this field. Sure. I don't know if they'll be successful or not now that we've got two big players, but more competition is always good. And there's lots of small service providers too that can do things like this. But what they'll do for you is they'll run all that information on their hardware and they'll just let you connect to it, which is nice, right? So we can just scale out and use their resources. We just connect to it. So there are different types of databases. And then another way of categorizing it is the type of information that goes in. We have general purpose, right? Stores all sorts of things everywhere, all varieties. And you might also have a discipline specific database that stores just pieces of information on a very specific type of information, right? So if all we need to do is store this and we want to have lots of information about just this piece of information here, we use a discipline specific one. It doesn't need to be general purpose. And then you can tune it to be very performant for that one use case. It's not just a general database that you can throw anything and everything at. So other ways of classifying databases, we have operational databases. Operational databases. These are places where we store all of our operational databases, or I'm not a fan of this acronym, but that's okay. It's an OLTP, or online transaction processing. The idea with the transaction is, hey, if we are Walmart or Meijer or Kroger or any company, every time we make a sale, we're going to enter a transaction into the database, right? Sold these things, sold these things, sold these things, sold these things. So at any point in time, we'll know exactly what's in the store, aside from dealing with a little bit of, what do they call that, shrink from theft and broken products and things just getting misplaced. We essentially know exactly what's in the store. Right, because that is our online transaction processing database, or our production database. It runs our operations. So its job is for us to log everything that happens. When new products come into the store, we're going to scan them in and say, okay, I've got these new things on the shelf, got these new things in the warehouse, got these things, I need to put them on the shelves. Right? Okay, I put these ones on the shelves, great. Oh, I need to move these ones to a particular location because they're getting put on an end cap for a big sale that's coming up. Whatever it happens to be. That's our transactional database. So its job is to be performant enough so that every single register across every single Walmart in the country can be entering this data as we sell it. Boom, 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 boom. Every transaction gets logged in the database real time. Right? Because that way we can get better information off of it. Another type of database is its focus isn't on operations, it's on analytics. So with an analytical database, the idea is we want to take the data that is typically in our transactional database and transform it so we can get information out of it faster. So a lot of times we'll call these the OLAP. So that's our online analytical processing, right? So instead of transactional, it's analytics processing. You might hear the term business intelligence, right? That's our technical term. Business intelligence. The idea that we can derive better information and make good business decisions from the data that we're analyzing in our analytical database. Okay? Some of the things that we'll do with these is you might build a data warehouse. So a transactional database is designed so we can have the transactions, right? Just like that's our production database. We want to enter transactions real time as things are happening. The analytical database is structured differently. So a data warehouse is structured in such a way that we can better analyze the data. So it's not tuned and designed for fast transactions. It's tuned and designed for better intelligence gathering. Okay, and there's a whole specialty field getting into how we do data warehousing. We'll talk about that later on, but just know that it's different. Okay, but both of these types here typically rely on structured data. Structured data, right? We need the metadata that tells us about the data. Here's a date. This is the sales date. Here's a date. This is the expiration date. Here is the lot number for this, or the model number for this in case there's a recall. All these pieces of information and the metadata about the data that goes in, right? So that's all of our structured data. There is another type of data called unstructured data. Unstructured data. Now, if you've ever been to a hospital, you'll know there's all sorts of forms and reports and things that happen, and typically a report is unstructured data. It's just the doctor saying, blah, 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 you had this diagnosis, we did this thing, da, 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 going through the whole piece of information, everything about what's happening here. And there's no structure to it, there's no form to it. It's just a big blob of data that's unstructured. It's really hard to take that unstructured report that, so-and-so patient, so-and-so diagnosis, so-and-so treatment, so-and-so medications, da, 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 here's the plan, come back in 3 weeks, whatever happens to be, and get structured data out of it. We can't say, oh, this particular line here is a date. This particular thing right here is when you need to come back for a follow-up. This particular thing here is a medication. You can't really do that very well with unstructured data. So that structured data, right, the idea that we're going to have metadata and be able to break it down and add to it, right, so we can have better intelligence is huge. But with unstructured or maybe even semi-structured database, a semi-structure is similar to the unstructured, but we're going to say, hey, here's a grouping here of data, and we know everything in here belongs to that. There's a little bit of structure. Here's another group of data. Here's a bunch of stuff here. So we have some little bit of structure around it with our semi-structured data. This is typically better, right? Unstructured is really hard. Semi-structured is better, but structured data is the easiest for us to work with, but typically the hardest for end users to enter, right? If you've ever talked to a doctor about electronic medical records, a lot of them don't really like it because there's a lot of work up front that goes into entering data in a structured format. That, hey, let's go through the list here, enter all these things. Instead of them just writing down one big report, they have to go through and they have to check all these different boxes and do it in a very particular order and very structured manner, and it changes their typical workflow. But a semi-structure, a lot of times you'll get XML, which is extensible markup language. It's a way of adding some structure to data. So you have a semi-structure. You might also have JSON. That's a another way of storing data. This one's very popular in the web. Book doesn't actually mention this one, but that's another very popular semi-structured way here. So dealing with these types of data are difficult in a typical database management system that's meant for structured data. So we have some ways to go about it. We've got some options here, and newer types of databases, you might hear the term NoSQL or NoSQL databases. Right? This idea that it's not only SQL, right? It's designed for additional things. I mean, we haven't really talked about what SQL is yet, but we'll get there. That's our traditional database language for interacting with databases. Our social media platforms just have massive amounts of data. It just won't function properly in a traditional database management system that has this very structured format, right? And a lot of it's meant to be this unstructured data, just have a bunch of, we'll just throw some stuff out there. So maybe we have some structure to it, but some mix of pictures, some mix of words, whatever we want to throw out there. And we need new ways of storing that. So we'll get to this NoSQL or not only SQL style formatting in a little while. There's just all sorts of different ways to classify databases here. Around the number of users, around the location, around what we're doing with the data, whether or not it's operational or analytical, whether or not we're storing structured or unstructured or semi-structured data. There's lots of different ways of classifying. All right, thanks, folks.